Our session today will be on what is called the normal distribution. The normal distribution. So normal distribution has a number of properties that we need to align ourselves to before we go into the calculations. So when we're dealing with normal distribution, we're looking at the following properties. Number one, a normal distribution has an asymmetry. Asymmetric property means mean, the mode, and the median are all at the center. So this is how I can illustrate it. So it is bell-shaped. It's asymmetric, meaning the left side mirrors the right side, means on this side. So this is our left side and the right side. Then at this center here, our mean, our mode, our median are all what? Equal. So this is one property that you need to know. The second property is that it is bell-shaped. Like I said, it looks like this, like a belly. It's bell-shaped. Then also, you must understand that the area under this graph is equal to what? Is equal to 1. So each quadrant here has 50%. So we're 50% on the left side and 50% on the right side. All right. So also the tails do not touch the base. They're infinite. The tails don't touch the base, they're infinite. So they go forever. Are we together? So we also should understand that it is asymmetric. It's approximately follows an empirical rule, where 68% of the data is within 1 standard deviation, and 5% within 2 deviations, and 99.7 is within 3 deviations. So these are the key properties that you need to align yourselves with for what we call the normal distribution. So now I'll take you through mini calculations, but firstly, we need to understand how to read the tables. So this table here we're going to look at will be an X-ray to you. So we understand how doctors are able to be indifferent by firstly understanding how to read this table. Okay. So these readings that we have here, as you can see, it's a cumulative table, have readings up to 100%. So if I tell you to read, give me the reading for 1.25, 1.23, for instance. The first two numbers, you get them from this horizontal angle. So we go under 1.2, and this is 0.03. We go under 0.03, where they meet. What is the reading? 0.8907. 0.8907. Can somebody help me? What is the reading for 1.47? 1.47. What is the reading?
Zero point 929.
We go to under 1.4 and under 7. So 1.4 under 7 there. We're going to find 0.9292. So this is reading the normal way. So now I would also ask that we consider the reverse. So if I told you that this 9292, what is the Z from the probability? So this Z, 1.4 and 0.07. Okay, so you say this is 1.47 if we're going to read from reverse. Okay, so let's go to give me the reading for 0.9750. Can you give me the
1.86.
So we look
Is
for
it
it on
1.8?
inside. What are you finding?
1.86.
Are you sure? Zero point 9750. It is
The
this
1.96.
1.96.
1.96, correct. So here we're reading from the what? From the probability, from the P to the Z. Sometimes we not have the exact one, you get the closest possible. So help me find the Z for 0.9116. This is the probability. Give me the Z for 0.9116.
$1.35.
1.35. So the closest is which guy? So 0.9116. The closest is this guy here, right? So
Yes.
1.35, correct. Are we following? Because this is very key, understanding how to read the table from inside to outside. Those that have just joined us now, we're learning how to read this so-called Z table. So we talked about 4 key properties. Can you remember quickly what are the 5 properties of the normal distribution? Number 1, what did we say?
It's symmetric, meaning the mean, the mode, and the
Correct.
median.
Meaning the mode, the mean, and the median are all at the center. Number 2, what did we say?
It's bell-shaped.
Bell-shaped, correct. Meaning it looks pregnant, right? It's like this. Number 4, what did we say?
The tails do not touch the base.
Okay,
It
tails
is
don't
infinite.
touch. It's good. Tails are infinite, correct. The last one, what did we say about the properties?
It follows an empirical rule.
Good. It follows a empirical rule, which means that for every 1 standard deviation, that's 68% will fall within. For every 2 standard deviations, what was that? 95. And 3 standard deviations, 99 point what? Yeah. Right together. All right, so with that being said, we also learned how to read from P to Z. From P to Z. So let's read, we said when you're reading figures like 2.1.23. All right, so we also learned how to read the tables. So we said if you have 1.23, we go here under 1.2 and 0.03 where they meet. All right, so we said under 1.23, what we did we do? We went to 1.2 and 0.03 where they met. This is 0.9807. So this basically means that the probability, the proportion from this side here. So this is 0 here and 1.23. So this is 50% we know, plus this part there. So the total was giving us 0. What? 0.8907 what? 0.8907. So this is approximately 89%. So this is 50 and maybe this is 39%. So 89%. So that's what it means. All right. Then we also learned how to read from inside the table. We thought that if you're given a probability of, for instance, 0.959750, we can find the Z for this one. So Z, we simply fetch it inside the table. We go to 0.9750. So just add 1.96 and 0. These two. So when you add these figures there, we get 1.96. However, we also say that sometimes we may not find the exact figures. You may find something close. For instance, 0.911, instead of 115, you find 116. You can get the closest possible. So this will still give us 1.35. 1.35. All right. Are we now on the same page?
Yes.
Right. Now, this is what we call standardization. We have Z is equal to what? X minus mu over standard deviation. This is what we call standardizing. If we have a sample size, sometimes we say Z is equal to X minus mu standard deviation over square root of n. Now, let's go to our grade 1. When we say, for instance, Z is greater than 1.96, and we say Z is less than 1.96. So we are basically looking at shading signs. So 1.96 is here. So greater means shade right. So greater means what? Shade to the right. If we're told less than 1.96, so 1.96 is a positive, all positive numbers are on the right side here. We are shading on the less than. So less than, we shade on the left, L for L. So something peculiar about the shadings. This shading here, it is a small shading. So meaning our answer here is less than 50. Then this shading is a big shading. You can see. So it's a big shading. So I'll tell you what to do when the shading is small. I'll tell you what to do when the shading is big. So from the properties, we're told that the area under graph is equal to 1. So I'm going to teach you 4 steps that you need to know. I call them ISA. Step 1, you need to learn how to illustrate. Step 2, you need to know how to standardize, how to shade. Step 3, you need to know how to standardize. And step 4, you need to know how to apply the principle. But let me start with already standardized figures. So if we are told Z is greater than 1.23. So we illustrate 1.23 is on the right side. So we're going to put 1.23 there. The sign is greater, so we're going to shade on the right side here. So we've done illustrated, we have shaded, standardized is already in Z. So we're going to apply. So whenever the shading is small, our application is we subtract from what? From the 1. Because if, for instance, this is 20%, the remainder is 80% because we subtracted 1 minus 0.2. So how did we get the 1.23? According to our first lesson, we said 1.23, go under 1.2, then under 3. 0.8907. 0.8907. So this is 0. So from here, sorry, to here, 0.8907. So this is about 89%. So clarify, if this is 89%, how do we find the small region here? the probability of Z is greater than 1.23, we're going to definitely do what? Subtract 1 minus 0.8907. All right. So what's the difference? One minus 0.8907, which is 0. What? 10.
0.1093.
Correct. So this is a 10%. All right. Sometimes we told the other side, Z is less than 2.0, negative. So all negative values are on the left side of 0. So our 0 is here, our -2 is here. So left side, which side are we shading? On the left side. All right. Now I need you to ignore there's a negative table, but for now ignore it. Let's concentrate on the positive table. So 2.0 is what? 0.9772. So this is the shading. It means that the shading is the big side. It can't be from here to here. It's from here to here, which is 90 what? 2.97. You need to use some logic here. So this means that from here to here is about what? 97%. So how do you find this region which is small? Remember I said if it's a small region, what we do? We subtract the probability from 1. Big reading, we read it directly. So here we're going to subtract from 1. What are we going to get? One minus 0.9772. Again to get 0. What?
0.0228.
Correct. How about if we said find the probability of Z greater than -1? So again, we illustrate. Our 0 is in the middle, our -1 is there. You put your divider. Which side are we going to shade? The left or the right? Greater means what? Right. So we're going to shade to the right. Already, what does the shading tell you? It is a big shading. So whenever the shading is big, we just read direct as it is. So let's go and check where 1.0 is. So 1.0 is what? 0.8413. So do we need to subtract from 1? No. 0.8413. So this whole region there is about 84%, which makes sense. All right. Now, the instances when you're not given the Z, they just say the mean is 10, the standard deviation is maybe 3. Find the probability of X, not Z. X is greater than maybe 16. Then you find the probability of what? X is less than 13. Or find the probability of what? X is less than 6. So we can do the ISA that I talked about now. ISA stands for illustrate, shade, standardize, and apply. So we're going to illustrate here. The mean is always found in the middle. So our mean, we know is 0, but the actual figure I've been given is what? 10. In our X, so this is a column for the Z, this is a column for the X's. So we need to change the currency, for instance, kwacha into dollar. So here we've been given a kwacha, or our 16 there. So we cannot find a 16 if you go to the what? To the Z table. There is no 16 here. The biggest number, in fact, is what? It ends up with 0.6. So we need to standardize it into a readable figure. So remember the formula for standardizing, it is Z is equal to X minus mean over standard deviation. So this 16 minus 10 over standard deviation is what? 3. So 16 minus 10 is 6. 6 over 3 is what? 2. So now we know that this 16 is equivalent to 2. We put our divider there. So now we can shade illustrate, shade, we're shading to the right because right is associated with greater. Then standardize, this 16 is converted to 2. Then apply. This shading is what? Small. What is the application when the shading is small? We usually subtract from. So you can say x, probability of x is greater than 2. Or others will say probability of x is greater than 16. It's the same thing because 16 is what? As good as 2. So we're going to subtract 1 minus, what is the reading for 2? You go into the table here. Under 2.0, it's 0.9772. 0.9772. So the difference here, 1 minus 0.9772, here we get 0.0228. So it makes sense that this region is just 2%. So the ladies and the gents here, please lead us through using ESA. So let's start. The ladies, step 1, what do we do? Illustrate. So our mean, what is that our mean? We know 0. Our mean is 10. Then let's identify 13. Is 13 this side of 10 or this side of 10? It's obviously on the right side of 10. Then we put our divider there. Then it says less. So step 2, shade. So we're shading to the left side. So what does the shading tell us? The big shading. So when we read, we don't need to subtract, we get it directly. Then standardizing x minus mu, so 13 minus 10 over standard deviation, which is 3. So 13 minus 10 is 3. 3 over 3 is 1, negative. It's positive, in fact, so positive 1. Then we go to check for the 1 from the table. So 1.0 is 0.8413. So the probability of x less than 13, are we subtracting from 1? No. We read direct 0.8413. So it ends there because this is a big shading. All right, let's say x is less than 6. So we know our 0 is here and our 10 is there. Now this 6, most people make a mistake. They're putting it based on the 0. No, it's an x. So x is based on the x value. So 6 is based on what? This 10. You put your divider there. Then saying less than. So less than, we're going to shade on the left side. Oh, this is a small shading. So since the small shading, the answer we're going to get, obviously, we're going to subtract from 1. So let's standardize this z. So 6 minus 10 over 3. We're going to get 4 over 3. You leave it to 2 decimal places. So 1.33. So 1.33 negative is where our figure will be. So we go into our table. Can somebody tell me what's the reading for 1.33? 1.3 and under what? 3. So it's 90, 82. So this means that the reading from here to here is what? 90, 82. So how do we get the reading? X is less than 6. Basically, we're just subtracting 1 minus 90, 82. All right, why are we subtracting? Because the shading is what? Absolutely small. All right. So what do we get when we subtract 1 minus 90, 82? We get what?
0.0918.
0.0918.
0918.
So this small area is about 9%. Sometimes examiners are funny. They still give you the mean is 10. The standard deviation is what? Is 3. Then part A, they say find now x. Find x for which we are what? We are 2% greater. Then part B, find x for which we are what? We are 27.1% less. Whenever they give you the percentage, we now go to the lesson we're having of reading from inside the table. So the word greater here, all right, is telling us that we're cutting from this side here. By what percent? By 2%. So meaning what percentage has remained here? 98%. So this 98% in decimal is the same as 0.9800. So we're going to go into the table and look for a number that is close to 98% or 0.98. So we check inside. Can you help me? I taught you how to find which number is close to 0.9800.
Could it be 2.06? 9803.
Why not 2.05? Which one is closer of the two? 2.06 or 2.05? One is above by 3, one is below by 2 points. So 2.05 is more accurate.
Okay.
Right? So otherwise you're okay. You're on the right trajectory. Did you get what I'm saying? 2.06 could be an alternative answer and the marking key is correct, but to be more accurate, 2.05 is more closer. So meaning our Z here is 2.05. So we want to find what X is. Now here we say Z is equal to what? X minus mu over standard deviation. Our Z is 2.05. Our X, we don't know. Our mean, we know it's 10. And our standard deviation is 3. So here you cross multiply. We're going to have 2.05. And you're going to have X minus 10. So when this X goes inside, it will add. So what is the value of X? This is 6.10 plus 10, 16.10. So this makes sense that our X here will be 16.10. It's on the right side. Conversely, here we are told for which value of X are we 7.1% less. Okay. So we are going to go on this side here. So we're going to cut off 27.1%. So what are we going to remain with this side?
Should be 63.9.
Okay. 100 minus what?
That
27.
should be 72.9.
We find what? Confirm. 100 minus what?
72.9.
72 point what? 9.
0.9.
Which is 0.7290. So here we know that our mean is 10. Then we don't know what our Z is, but we can check from inside the table. Let's look for 0.7290. 7290. Let's look for 0.7290 inside the table. Which one is close to 0.7290? This one is the closest, right?
Correct.
Yes.
So what's the reading for what's the Z for this one? 0.61.
1.
So since it's on the negative side, we're going to say this is negative 0.61. We're looking for the X because it's on the left side. So Z can be negative, but probability can never be negative. So here we're going to get negative 0.61 is equal to X minus 10 over standard deviation, which we have 3. So we cross multiply. So our x will be what? 10 plus 3, 0.61. What we get as the final answer of x? It's a negative. What do we get? Quickly. Just punch it 10 plus 3 times point
Is it 11.83?
11 point. What's the negative?
83.
You subtract. So it is 10 minus the answer we're going to get here. 3 times 0.61. Then we're going to get 8 point what? 17. Which makes sense, should be on the left side. So this is 8.17. All right. All right. So this is how we deal with our normal distribution. Okay, so we are only remaining with intervals, how to deal with intervals, then we are done with the topic. So in the case where we have probability, the mean is 10, the standard deviation is 3. And they ask us to find the probability between 7 and 16. The probability between 13 and 16. The probability between 4 and 7. So what you need to understand is the kind of intervals we're having here. So our mean is between what? 10. So we have 7 and 16. So here, if we're sandwiching our mean in between, you standardize 7 minus 10 is 3. 3 divided by 3, what do we get? Negative 3. Negative 1, sorry. 16 minus 10 is 3. 3 divided by 3 is negative what? This is 6 divided by 3 is negative positive 2. So these are the z values now. So whenever they're opposite directions, you get the z for the big number and the z for small number, you add them, then subtract 1. So our z for 2 plus the z for 1 minus 1 in total. So if you check, the z for 2 is 0.9772. The z for 1 is 0. What? 8 what? You must have these at your fingertips. 8413. And you subtract a 1. That's the gist. So if the opposite directions, get them individually, ignoring the signs, of course, then subtract a 1 there. So that's how we find the final answer if they're on opposite directions. So in this case, we're going to say 0.9772, 0.9772 plus 0.8413 minus 1. So we're going to get 0.8185. As long as they're in opposite directions, we're going to get subtract 1 and the other. You add the negative and the positive one and subtract 1 ultimately. But between 13 and 16, they're on one quadrant. Between 13 and 16, what's happening? Our 10 is here, our 13 is here, and our 16 is there. We know standardizing this is 0. 13, the difference is 3. 3 divided by 3, it's 1. Here, 10 minus from 16 is 2. 2 divided by 16 divided by 6 divided by 3 is 2. So we're looking at this direction here. So whenever they are on opposites on one side, just get the bigger z minus the smaller z. So the z is equal to 2. What is our probability? 0.9772. How about the probability of z is equal to 1? This is 0.8413. Just subtract these two. As long as they're on what? Same side. We only add and subtract 1 when they're on opposite sides. But same side, this is what is happening there. Anyone behind so far? Have I rushed you so much at the intervals? Because this is where most of the marks. Right. So lastly, it's also the same 4 and 7. They're on the other side. So we have 4. Here we have 10. We have 7. We have 4. They're on the left side, but on the same side. The principle is as long as on one side subtracted. So 7 minus 10 is -3. -3 over 3 is -1. 4 minus 10 is -6. -6 over 3 is -2. I picked these numbers because they're easy for me to remember. So the key principle is as long as I'm on same sides, ignoring the signs, the z for -2, it's 0.9772. The z for -1, 0.8413. And just get the difference there. All right. So the logic here is they should be on the same side. Are we together?
Yes, we are.
So this is the principle. Now, I need you to understand that any question that will come in this course pertaining to that, you are able to answer because I've explained all possible ways they could be twisted. So here is an exam type of a question. Suppose the selling price of various houses as a normal distribution. You always be taught it's normal distributed. Standard deviation 276. Mean is 276. Standard deviation is 32. What's the probability that they are more than 206? When you're in the exam, you'll be laughing. Say, why is this for me? And this carries so much marks. You would wish they even make it a little bit complicated. So just to guide you, because this will be your homework, what is our mean in this question? Our mean is what? 276. 6. Our standard deviation is what? 82. You can stop at the zeros if you want. But A has a probability that there'll be more than 206. So they're asking for X is greater than what? 206. Using ISA, step 1, illustrate. Our mean is what? 276. Our 206 is somewhere here. So when you're saying greater, obviously shading is bigger. The reading we're going to get is what? Read it directly. Simple as that. But 2, it will sell for less than 220 or over. My students really smile when they come to such questions because I'd have done more than enough. So less than 220. Using ISA, illustrate. 276 is here. Then here 220 is here. Which side are we shading? Less. And this is a small shading. What do we do? The answer we get is subtract. Aren't you smiling at these easy questions? Then the toughest of them is between what? more than 250 but less than 350. Obviously, this one is an interval. What are they asking for? Interval. Here it is 276. And we have what? 250 and 350. So here they're looking at a sandwich situation. 250, 350. So here we get to standardize each of them, add their probability z, then subtract 1. And that will be your homework. Are we done? Are we together?
Yes, we are.
All right.
Yes, we are.
So we are done with this topic. Unless there are any questions. So I'm going to make it harder for you to fail than to pass unless you just want to fail. All right. So we end here. Our next class is at 20:30. Thank you so much for your time.